Hey, Alice Miss Johnson. Welcome to Unit 2. I had filmed a short, high level philosophical overview of the unit, but now we're going to get down to brass tacks and learn about limits. All right, so I've got two definitions of the limit. The first one is kind of the more mathematical one, and the second one is more of like a what's going on here. So the definition of a limit is what a function approaches as its x values get closer to a specified number or a specified value. Okay, and what that means is the limit of a function is what's going on near that function near a point x equals a, so just like x equals 4, x equals -3, whatever. And you're ignoring what's actually happening at x equals a. It's just what's happening around it, right? It's a way for us mathematicians to talk about kind of what a function's tending towards rather than what it actually reaches. And the limit notation, I'm gonna get green, it's my favorite. Limit notation, you'll usually see it written either as LIM or LIM. I'm gonna use cursive because I like cursive better. It's the limit of this function as x gets closer to a number. And it equals something, right? Actually, we usually write this as L. It is possible that the limit does not exist. If you've seen the movie Mean Girls, Katie goes to a math competition, and spoilers for Mean Girls, seriously pause it, but spoilers for Mean Girls, she yells, "The limit does not exist." And that's something limits are allowed to do, not exist. Okay, and we're gonna practice some of these in a second, but before we do that, I'm gonna talk about handed limits. So when we're talking about limits for just regular limits, we've got this. Here's our a. We want to know, as our x values get closer to a, our y values associated with that seem to be getting closer to this number, right? And if we come from this side, it's much of the same thing. They're getting closer to this point right here, which is this y value. We call that the limit, right? There are handed limits. Sometime, instead of saying, where are both sides of the function getting closer to, we only want to care about the left side or the right side. So if we only cared about coming in from the right side, it's called a right-handed limit, approaching a from the positive side of a, right? And if we only care about the left side, it's a superscript minus, right? The notation here is you still have limit, you still have it approaches a from the left of f of x equals some limit, or the limit as x approaches or gets closer to a from the right side of f of x equals some other limit. We're about to figure out that when these two are the same number, the limit exists and equals that number. And when these two are not the same number, the limit doesn't exist. But let's explore that with some examples. Boom, example time. So here's a graph. Parts of it are continuous. There is a jump discontinuity, and we'll go into discontinuities more eventually. There's a jump, there is a hole, but the rest of it's continuous. So let's just go down and talk about the limits that I've written in. Okay, so the way we read this first limit is the limit as x approaches 0 from the right. That's what that plus sign means. So we're saying, okay, as we get closer to 0, our function seems to be getting closer to 0. And notice for this one, we only checked the right side. Okay, same thing. This one is the limit as x approaches 0 from the left of f of x. So here we're going to start drawing a function closer and closer to 0 from the left side. It seems like it's also getting closer to 0. Because these two are the same number, because the left-handed and right-handed limits of x approaching 0 are the same number, when we just say the limit as x approaches 0 straight, no plus or minus, it just is also 0, right? The two sides agree, we're doing good. Awesome. I'm going to go over here to -4, we're going to do the left, we're going to do the right, and we're going to do just the regular limit as x approaches -4. So from the left-hand side, as we're getting closer to -4, our function seems to be getting closer to -2. All right. As we approach 4 from the right-hand side, our function seems to be getting closer to 0. When we combine these two, and we just look at the limit as x approaches -4, it's not getting closer to any one number, right? When we're answering like what a limit is, or like the value of a function or the value of an operation, there are very few times in math where we're allowed to say, oh, it's either 0 or -2. If there's any ambiguity here, it means it doesn't exist. And DNE stands for does not exist. Okay, so again, the limit at -4 does not exist because there is a jump where the left and right hand sides don't agree. It's getting closer to two different numbers as you're getting closer to -4, and we say it doesn't exist. Let's do another color, purple. What is the limit as x approaches 3 of f of x? Because there's no plus or minus up here, it means we have to do both sides. We have to come in from the left and come in from the right. Both of these sides are getting closer to the number -2. When we actually get there, right, f of 3 does not exist, right? There's a hole. There's no other point. There's no, like, filled in point somewhere. Like, the function value doesn't exist, but the limit isn't asking that. The limit is just saying, what are we approaching? What are we getting closer to? So the limit as x approaches 3, as we get closer to 3 in the x value, we're getting closer to -2 in the y value. So the limit of 3 is -2. Right? For the limit as x approaches 5, as we get closer to 5 in the x's, we're getting closer to 1. And this one, honestly, we could have just plugged in 5 to the function because it's continuous. And we'll talk about that when continuity means you can plug things in, and when discontinuity means we have to do the limit stuff. All right, again, if we're going to x equals the limit as x approaches -1 of f of x. Over here, because it's continuous, we're just getting closer to -2. It's just the actual function value, so that's pretty nice. And then a look to the future. The limit as x approaches infinity. This is what we think of as like our horizontal asymptote or our end behavior of functions. As x approaches infinity, right? This is talking about what is the end behavior of this function. We could say like, oh, it's approaching infinity because it seems to be going off forever. But technically, we would say this does not exist. The answer for our limit is not supposed to be infinity, right? Limits, in order to exist, have to be measurable and finite. Measurable is a very fancy math word. Finite just means it has to be a number. All right? And then I'm going to jump over here, and we're going to do kind of the Jeopardy version where I give you the answer, and we want to come up with a question. Sorry. So for here, if I wanted to find the limit as x approaches a number of the function where it does not exist, one such number would be -5, right? And -5, from the right, we're approaching 1. From the left, we're approaching 3. Because those numbers are different, because there's a jump, the limit does not exist at -5, sorry. Another place where it doesn't exist is at -8. That is because on the left-hand side, it's approaching positive infinity. And on the right-hand side, it's approaching negative infinity. Those two numbers don't match up, so it does not exist. I'm going to not do this one. I'm going to focus instead on this one, where this one I'm actually talking about +8, where the function on the left and the right both go off to infinity. And this is when we have a vertical asymptote. So sometimes we like to say like, oh, it's sort of going off to infinity, but actually the limit does not exist because, again, limits have to be finite. Cool. Yeah, so on your assignment, there is just going to be a bunch of limits that look like this. There's going to be a graph. There's going to be a bunch of limits. Some are left-handed, some are right-handed, some are just plain. Try your best. Fill them out, submit them either by taking a picture of your work and submitting the pictures, or by just typing straight into the document and uploading the document. As always, if you have any questions, email me, message me on Schoology, message me on Teams, come to office hours. Thanks. Bye, guys.